Inverse of a relation. Let us consider two non-empty sets A and B, and if R is a relation going from A to B, then the inverse of this relation R, which is denoted by R to the raised to the power of -1, that's called the R inverse. It is a relation going from B to A, and it's defined as R inverse equals to the set containing the ordered pair B and A. So what we have done, we have reversed the order of the ordered pair such that the elements A and B belongs to the relation. Let's understand this with the help of an example. Let us consider two non-empty sets A and B with some values given by. So set A has the elements A, B, C and D, and set B has the elements 1, 2 and 3, and the relation R going from A to B is given by four ordered pairs A1, C1, D2 and C2. Let's try to find out first the domain and range of relation R. So the domain will be the first elements of the ordered pair, so those are A, C and D. Now the range of the relation R will be the second elements in the above ordered pair, or the ordered pairs in the relation R. So the second elements are 1 and 2. So now that we have the domain and range of our relation R, let's try to find out the inverse. So the inverse relation will be simply equals to R inverse. As per the definition, we have the ordered pairs, the elements are flipped. So the first ordered pair for the relation R is A1, so we'll flip the elements and that will give us 1 comma A. Then we pick up the second ordered pair, so which is C1, and the inverse will be 1 comma C. Then the third element is D2, so the inverse of it will be 2 comma D, and finally C comma 2 will be written as 2 comma C. So this is how we determine the inverse of the given relation. Now let us try to find out the domain of this inverse relation. So the domain of the inverse relation, if the inverse of relation R will be the first elements in the above ordered pair, so that is 1 and 2. Similarly, we can find out the range of the inverse relation. So the second elements are A, C and D in the above ordered pair, so the range of R inverse will be A, C and D. Now clearly from the two values, we see that the domain of our relation R is equals to the range of the inverse relation. They both have the same set of values, and the range of our relation R is equals to the domain of the inverse relation. So domain of R inverse is equals to range of R. Let's try to understand graphically what is the meaning of an inverse of a relation. So we have the relation R going from A to B. So that means when we choose the element A from set A, then this corresponds to an element 1 in our set B. And when we choose an element C in our set A, that corresponds to an element 1 in set B. And when we choose the element D in our set A, that corresponds to 2 in set B, and the element C in set A corresponds to 2 in set B. So this is a relation going from A to B. Now the inverse of a relation means we are coming from B back to A. So let's look at it. So if we have, when we have, this is the relation that we are going from B to A. That's how the R inverse is defined. So if we pick up 1, then we should get back A. So we're going along, we are actually backtracking our path, or we can say backtracing our path. So when we choose 1, we should get C. So that is available here. If we pick up 2, then we should get, backtracking our path, we should get C. So here it's 2 comma C is present, and finally we should, starting from 2, we should get D. So 2 comma D, this is also present. So this is the meaning of the inverse of a given relation. Let's do another problem. So in this question, we have a non-empty set A containing the set of natural numbers less than 10 and a relation R on A, which is defined by the set of ordered pairs x and y such that x and y belongs to a set A, and x and y have the relation given by x plus 2y equals to 10. So let us begin by first writing down the values of A. So our A being a natural number less than 10, so we start from 1 all the way up to 10. And our relation R is given by the set of ordered pairs x and y such that x and y belongs to the set of natural numbers n less than 10, and we have the relation between x and y given by x plus 2y is equals to 10. So let us rewrite this equation in terms of y. So that will give us y is equals to 10 minus x divided by 2. So let us pick up one number from A. So when we pick up the first element from A, that is x equals to 1, so that gives us y value is equals to 10 minus 1 divided by 2, which is equals to 9 over 2. Now this is not a natural number and this does not belong to our set A. So this implies that the ordered pair 1 and 9 over 2 does not belong to the relation R. So now we pick up the second value, x equals to 2, and that gives us the value of y as 10 minus 2, which is 8, divided by 2 gives us 4. Now 4 belongs to our set A. So that means this forms an ordered pair. So we have 2, 4. Now this was going to belong to the relation R. Now we'll see similarly for x equals to 4, 6, 8, we'll get the values, we'll get the respective ordered pair, whereas for values 3, 5 and 5, 9 and 10, we're not going to get any ordered pairs, which is going to be defined under the given relation. So let's go to the next value, which is x is equals to 4. So that gives us y equals to 10 minus 4, which is 6 divided by 2. So 6 divided by 2 is 3, and 3 being a natural number, it belongs to our set A. So we have the ordered pair 4 and 3 belonging to the relation R. The next value will be x equals to 6, which gives us y is equals to 10 minus 6, which is 4. 4 divided by 2 is equals to 2. So 2 belongs to our set A, which is the set of natural numbers less than 10. So we get the ordered pair 6, 2 belonging to the relation R. And the final value will be x equals to 8, which gives us y equals to 10 minus 8 divided by 2. So 10 minus 8 is 2. 2 divided by 2 will be 1, and 1 belongs to our set A. So the ordered pair 8, 1 belongs to the relation R. So now that we have all the ordered pairs, so let us write it down. So our relation R will contain these 4 ordered pairs 2, 4, 4, 3, 6, 2 and 8, 1. This satisfies the conditions that x plus 2y is equals to 10. Let's write it down. X plus 2y is equals to 10. Now we have to find out the value of R inverse, the ordered pair that comprises the inverse relation. So that will be simply, we'll take the first ordered pair, which is 2 and 4, and we're going to flip the values. So that will be 4, 2. The second one will become 3, 4. The third one will become 2, 6. And likewise, the fourth one will be 1, 2. So this is the ordered pair, the list of the ordered pairs that can be found in the inverse relation of R. So we can find out the domain of our inverse relation. So that will be simply the list of all the first elements in the ordered pair. So that's our 1, 2, 3 and 4. And its range will be range of our inverse relation. R inverse will be simply equals to all the elements found in the second elements of the ordered pair. So that will be simply 2, 4, 6 and 8. So if we compare the domain of R inverse with the range of our relation R, they will find that they will be exactly equal, because the range of R, let's write it down, the range of our relation R will be the second element of the ordered pair of R. So those will be 1, 2, 3 and 4. So we see that the range of R is exactly equals to the domain of the inverse relation. Then we find out the domain of R, which will be the first elements in the ordered pair. So that will be 2, 4, 6 and 8. And this value is exactly equals to the range of the inverse relation.